Hello and welcome everyone. In the continuation of the last topic, we have done a few days back. So I come up with the next part of this topic, arrays. So let's move ahead and understand the further integrities of this topic. So in the last lecture we talked about the one-dimensional array, right? So what was that? That is a collection of the similar types of items put together, right? So that you need not to have the multiple variables declared for a particular thing in your program. So in continuation of that, there is another concept is two-dimensional array. And as we always see first the syntax of declaring it. So in C you need to have this data type first, the name of the array and the rows and columns. So I'll explain that how it works in program, but just to make the understanding clear about the syntax, first we need to have the data type for which type you want to create the two-dimensional array, and then a name. As in the one-dimensional array we have the similar syntax, but there was no another subscript, right? There are two subscript here. In the one-dimensional array there is only one subscript, right? Now here is an example. This is the data type, this is the name given to the array, and these are two subscript rows and columns, right? Rows and columns. So this is how we declare array. So now how to interpret this information in the form of a visual, right? So that we have an understanding that how it will be represented into the memory, right? So I'll start from the array index always start from 0, right? So this index means for the row index will also start from 0, and the column index will also start from 0, right? And then the traverse will happen. So this is row 0 and this is row 1, right? And this is column 0, column 1, right? And column 2. So here we have 2 rows and 3 columns, and the index will start from 0, right? When we see the arrangement of the array elements, then the first element as a representation will have 0th row and 0th column, right? Again, the row is fixed. This is 0th row. So 0th row and first column. The column is first, right? This is first. 0, 1, 2. 0, 0, 0, 1, 0, 2, right? 1. Now the one row is fixed. 1, 0, 1, 1, 1, 2. Right? This is how it is represented. And this is how you can visualize it when you're writing a program, right? It is easy to visualize in this way so that you have a clear understanding of how to traverse the array elements. Okay? And the same in the presentation also, it is which I just explained, it is referred, right? Column 0, column 1, column 2. Now here is the representation. Let's suppose you have this number at this place, right? This number at this place. So at one point of time, how many numbers you can store is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And this is for 2 rows, 1 row, second row, 2 rows, and how many columns? 0, 1, 2, 1, 2, 3, 4, 5. So 5 columns. So 5 into 2 equal to 10. So this is how 10 numbers are there. You can represent through this array which you have declared like int a, 2 rows and 5 columns. So 10 elements you are representing here, right? Now, two-dimensional array initialization. So I want to bring your focus back to the one-dimensional array, then you will understand that how it is represented. Now here we have two subscripts, right? But in case of one-dimensional array, which are included in this single subscript, right? And it will start from the index 0, index 1, and index 2. Now, if I would say you have two-dimensional array, then it means it will be collection of one-dimensional arrays, right? So the representation would be looking like this. For again adding one subscripts like 4, and I am changing it. Let's suppose we have two rows only. First is rows and second one is column. So column is same, right? These are columns for every element, and then we have two elements, 1, 2, 1 this, 1 plus 1 equal to 2, right? So these are two elements within this array, and this array was like this for double dimensional. So it is a collection of single dimensional array, you can say, right? Two rows represent this set, 1 and 2, right? And this 5 is the columns within those sets, right? This is how two-dimensional array is initialized, and this is what it is written, which I just explained, right? Okay. Now, program to find addition of two matrix. If you see very carefully, right, this was how the representation of the array was, right? Two-dimensional array where it has two rows, row 1 and row 2. Of course, the index will start from 0 and 1. This is index and 1, right? Index. But it has two rows. So representation is in a form of matrix. If you see in mathematics, the matrix is represented like this, which can have two rows like 1, 2, 3, 4, 5, 6. So the similar way, if you complete this box like this, right? So it is same. We have seen the representation of array. So two-dimensional array are represented, can be represented in the form of matrix. So you can solve the matrix level problems of mathematics using the programming, right? Through this two-dimensional array. So we will see, we are seeing this, how we are going to do this. Now we have as a standard way of writing the C program, start from these files, right? Header files, and then header files, then main method, and then we have multiple two-dimensional. We will explain that why multiple arrays are required. Since we are doing addition of two matrix, so at least we need two matrices, right? And then finally, where to store? So it's again a sum of two numbers, right? You need to have one variable to store the output of the sum of two variables, right? So I guess in the same way, if you are adding two matrices, the result will be stored in another matrix. So the third matrix is for that, right? And I'll explain why these are required. The reason these are required is how many rows and columns you want to enter in this arrays, right? Rows and column, and then iteration of the loop. So we'll go through how we are going it, right? So again, I'm clearing this screen. Enter the order MNN, first string. You are representing rows and columns by MNN. This is rows and this is column. Now if we see it carefully, then we have row 1 and row 2 where the indexes start from 0 and 1, right? Now the traversing will start from fixing the value of the row and incrementing the column. So 0, 0, 0, 1. It is 0, 1, 2, 0, 0, right? 0, 1, right? 0, 2. This is how it is. Now 1, 0, 1, 1, and 1, 2. Right? This is how it will look like. This is how it will look like. Comma. This is how it will look like. Now, doing it in programming, you know that it has incremental value 0, 1, 2. Means the inner circle is incrementing and the outer circle is the same 0. For this is fixed, row 0 it is fixed. So to represent this, we know that we have loops, right? We can fix the outer loop with 0 value and the inner loop is incrementing. So here the outer loop representing row. What this is representing? Row. And what this is representing? Column. So this is representing row and this is representing column, right? Inner loop. Since it needs to be increased for every value of this. So for I equal to 0 at the first time, this j will go up to the number of columns. N, we have seen number of columns. So for 0 column, then it will increment, j value will increment to 1. So for 1 column to second column, so it will increase for the first value 0. Now when I is incremented from 0 to 1, when I will increment it for 1, again this loop from 0 to the number of columns will get executed. This is how we will enter the values in the matrix. And again, for representing or you can say the assigning the memory for a variable, we use scanf. The same way we are doing it for array, right? For every element in the matrix. So initially, let's dry run this. I equal to 0. This is first time execution of outer loop. Since this inner loop is the part of this outer loop, for this I equal to 0, this inner loop will get executed since it is within the body of this outer loop, right? So this complete block will get executed for this value. So now executed, I is 0, right? J is start from 0. So for I is equal to 0, initial value of j is 0, right? So again we are doing I or j, 0, 0, I and j, 0, 0. Next, since this value is fixed for the first time, since the value of the n, let's suppose you have input 3 rows. Here you have taken from the user that how many rows you want in the matrix. So you have take the same example. You have 2 rows and 3 columns, right? This is rows and this is column. M, N. M representing rows, number of rows it will iterate for outer, N representing column. So for first time, j start from 0, 0, 0, 0 value is fixed for first iteration. Now for second, j's value is less than, j will be incremented to 1, right? J will be incremented to 1, it will be 1. 1 is still less than number of columns, that is 3. So it will again execute it. I is fixed, 0, 1, right? So next value is 0, 1. And then again, j will be incremented to 2, right? 2 is less than 3, of course, then it will 0, 2. Now, j will again incremented to 3. 3 is less than 3, this is false. So it will get out of this curly braces, right? And then again the value of the 0 will be incremented to from 0 to 1, right? Second time, so 1. This value change 1, and again it will start from 0. 1, 0. Again, j will be incremented in the next 1, 1, 1, 2. Again, when the j will be 3, it will be false. Again, I will be until the time it is less than m for number of rows, right? So this is how we are scanning the values for the matrix. We are scanning the values for the matrix, right? So all these values will be there in the array. Now you have all the values in the array. All the memories are assigned to every variable, which are held in the array, double dimensional array for A, right? We need another matrix, second matrix, because we want to sum two matrices, right? So second matrix, again the same way we will input the second matrix. Again we have rows and columns. Same, there is no change here because we have fixed the rows and column for both of the matrices so that we can add them, right? So both the matrices are same. So let's suppose both the matrices looks like this, right? You have input 1, 2, 3, 4, 5, 6, right? And then 1, 1, 1. For an example, right? So it is matrix A, it is matrix B. So these are two matrices, right? And now we are adding this. So its 0, 0 element will be added to its 0, 0. Its 0, 1 element will be added to its 0, 1 element. Its 0 to add. Again, we are traversing row wise and then adding the values of both of the matrix. So the logic will be just after this. The logic will be adding the subscripts, row wise and column wise subscripts for both of the matrices and adding those numbers, right? So let's see how it is that. So the logic is same, row wise outer loop. This is outer loop for row, right? And this is column. So this is outer loop for row and this inner loop for column, right? Outer for row, inner for column, right? And then since first time the value of I will be fixed 0, it is 0, A 0, 0. Since the value of I is 0 and initially the value of j is also 0 and then plus, right? B 0, 0. Now what will happen to j? J will increment. It will be 1. And 1 is less than, of course, the number of columns. We have number of column 3. So for this one, 0. Next iteration within this loop, I is fixed 0 because we are still have j to get traversed, right? So 0 and 1. The value of j is 1 now. And then A 0. Value of j is incremented, right? 1 plus B 1. And for third time, again C 0, C 1, 2, sorry, because the value of j is now 2, 0, 2 plus B 0, 2. Right? We are storing the sum of every elements of both the matrices in the another matrix in the same order, right? Now the value of j after 2 is incremented to 3. 3 is less than 3. We are checking here. It is false. It will go out and increment the I. Now in the next iteration, the value of I which is fixed is now 1. Now, right? And then for j it will start from 0. 1 0 1 1. Same logic will apply for 1 0 1 1. And this is how every element will get executed to get the output, right? So here are two matrices which we are entering, right? 2 rows, 3 columns, right? 2 rows and 3 columns. So this representing 3 columns, this representing 3 columns, and this is row 0, and this is row 1, right? Similarly, second matrix, two rows we want and 2 columns in each matrix. 2 rows and 3 columns. Again for second, it is row 1 and row 2, or you can say from index we can row 0, row 1. Total is 2 rows, right? And this is column 0, column 1, column 2, column 0, column 1, column 2, right? Column 0, column 1, column 2, column 0, column 1, column 2. We would have represented it like this, right? 4, 7, 2, 6, 5, 9. And this is 2, 3, 5, 4, 1, 6. This is how we have entered the matrices. Now sum. So for sum, let's go back. 4 plus 2, 6, 7, 3, 10, 5, 2, 7, 6, 4, 10, 5, 1, 6, and this is 9, 15, right? This is how we have the output through the representation, right? This is how we have the output through representation. So how we have represented? So it is just to give you the background that we have taken first the rows and the columns. Then rows and columns are, when you take input from in the loop, it will be in this form, but visualize it in this way, right? And then the second matrix, visualize it in this way, and then how you do in maths, adding the row wise columns, right? 4, 2, 6, 7, 3, 10, and 5, 2, 7, and then we will get the desired output as this one, right? Let me erase all and then show you the output. 6, 10, 7. Correct? Right. So, transpose of the matrix. You have one matrix, you need to transpose it. So, let's suppose you have matrix like this. Right. So, how it will look like? So, you are transposing this in this way. 1, 2, 3, 4, 5, 6. Right? So, you have to make this kind of arrangement where you have this input and you want to achieve this output. So, you need only one matrix in this case, and then put your logic to change this in this order. Means the value which was there in the 1 0, right? You have to bring it to the 0 1, right? 1 0 need to be bring out into 0 1. So this is the logic. So I'm giving you this exercise so that you can have a good hands-on on this topic. It is very good program to have the clear understanding of how we are working on the matrices and even using through the programming constructs, right? Thank you so much.